Global Project, Third Dimension. Presence. The RVK Industry. The birth of a new era in aerostatic airborne vessel engineering.
An original project by Mikhail Shmelkov, The New Great Silk Road in the Sky. Author's project by Mikhail Shmelkov, titled New Great Silk Road by Air, abbreviated as NGSRBA, is a derivative of the Third Dimension project. In this structure, NGSRBA serves as the main source of financial foundation, making it possible to carry out the transition of humanity into the third dimension across all spheres of life. The goal of the project NGSRBA, based on its defined mission, is to ensure a stable and continuous financial flow of $500 to $600 billion per year to support the implementation of the Third Dimension project. This is achieved by utilizing airspace within the range of unoccupied altitudes from 1.5 to 9 kilometers and beyond for the aerial transportation of international heavy and oversized cargo using aeronautical vehicles, RVK, with ultra-high payload capacity of 3,500 tons through the territory of Russia in volumes matching the current deficit of transit cargo traffic, estimated by experts at $500 to $600 billion per year. This financial flow will serve as the foundation for the Third Dimension project. A video link describing RVK can be found below this clip. Implementation framework of the project NGSRBA. The author of the project has developed an implementation framework for the NGSRBA initiative. This framework ensures its guaranteed execution under the current conditions of modern industry and economy. Let us now examine the key components of this framework. Legend used in the diagrams. Symbol for the enterprise producing RVK. Symbol for the enterprise producing helium. Symbol for the enterprise producing deactivated hydrogen. Symbol for the RVK port. Part 1. The RVK Industry. The method for implementing the NGSRBA project is the creation of a specialized industrial sector dedicated to the production of robotic aeronautical complexes, RVK, with ultra-high payload capacity of 3,500 tons, along with their operational and flight infrastructure. This sector is defined within the NGSRBA project as the RVK industry. The scale of challenges to be addressed during the implementation of the NGSRBA project calls for the establishment of an entire economic sector that affects not only the financial dimension of the nation, but also virtually all areas of societal and governmental activity, up to and including international relations. At the core of this sector lies the industry of ultra-heavy aeronautical technology, a comprehensive system of activities encompassing the full range of properties and characteristics that align with the definition of an industry. According to Wikipedia, an industry is a field of activity, an economic sector that includes manufacturing, distribution of specific goods, including services as goods, related sectors, and the consumer audience. Main components of the RVK industry. Section 1.1, Regulations, Standards, and Certification. Section 1.2, Manufacturing. Section 1.3, Flight, Logistics, and Service Infrastructure. Section 1.4, Cargo and Passenger RVK Traffic. Section 1.5, Business Structure for Building the RVK Industry, based on the Operational Return Model. Let us examine each component of the RVK industry in detail. Section 1.1, Regulations, Standards, and Certification. The first and most critical issue in building the RVK industry is the establishment and government-level approval of airworthiness norms, production standards, and certification protocols for RVK systems. At present, these frameworks simply do not exist. The reason is straightforward. Such vehicles have never existed before, and therefore there has been no precedent for their standardization or certification. Without resolving this issue, the entire project loses its meaning. No matter how advanced or necessary the product may be, without proper certification and standardization, it will remain confined to the hangar, at best eligible only for a demonstration roll across the floor. In addition to the RVK systems themselves, the process of standardization and certification must also encompass all supporting infrastructure, both ground-based and aerial. This includes flight routes, navigation corridors, and operational zones, none of which currently have any established norms or regulatory frameworks. These components are just as critical to the safe and legal deployment of RVK systems and must be addressed at the same foundational level. All of these standards must be substantiated and formally approved at the government level, directly within the process of developing the design and engineering documentation. Once approved, these standards will impose constraints on critical systems and components of the RVK unit, which means they will directly influence its design. Therefore, the link between the design process and the approval of standards is extremely tight and must be executed synchronously and simultaneously. If the approval procedure stalls in a bureaucratic office, the entire project will stall, instantly and entirely. In this context, we recognize the critical role of government support in the project. The RVK initiative does not require direct financial assistance or state investment, as it is a self-sustaining business product capable of independently attracting the necessary funding. Government partnership is envisioned in the form of maximum administrative facilitation, particularly within the regulatory bodies responsible for approving norms, standards, and certification procedures. Naturally, we will not reject financial assistance from the state, but only if it comes in the form of project-based financing. In all other cases, the form of government support described above will be fully sufficient for the successful implementation of the RVK initiative. This approach is also strategically beneficial for the state. Accelerated implementation of the RVK initiative will position Russia as the global leader in the production of ultra-heavy airlift vehicles, a category for which no country has yet established a manufacturing precedent. The emergence of Russian RVK traffic on the international cargo market will enable Russia to shape and dominate global standards for the production and operation of such systems. This, in turn, will yield substantial economic advantages and political leverage on the international stage. A video link describing RVK traffic is available below this presentation. There is one more critical aspect to consider. All revenue generated by the implementation of the NGSRBA project is directed into the distribution system of the Third Dimension Initiative, known as the TRIZM distribution system. This system prohibits the outflow of funds beyond Russia's borders. All resources are reinvested exclusively into the internal development of the project and the community of individuals actively involved in its realization. As a result, Russia gains a unique opportunity to reformat its existing social structure, not through upheaval or revolution, but through a transition to the third dimension economic model, TRIZM economy or equal distribution economy, built upon the principles of the TRIZM system. More details on the TRIZM economy and distribution system will be presented in our upcoming episodes. Section 1.2, Manufacturing. According to preliminary estimates, in order to eliminate the deficit in transit cargo traffic across Russian territory, currently valued at $500 billion USD annually, it will be necessary to build 3,263 RVK units, each with a payload capacity of 3,500 tons. This figure defines the scope of the production program for the launch phase of a dedicated industrial sector focused on the manufacturing of ultra-heavy airlift vehicles, RVK, along with their operational and flight infrastructure. It is self-evident that producing such a fleet, with vehicles of unprecedented size and mass, never before constructed anywhere in the world, will require the creation of an entirely new industrial ecosystem. This includes not only the manufacturing of the core vehicles themselves, but also the development of all supporting infrastructure, both aerial and ground-based, from scratch. It is also quite evident that the creation of this industry will require a substantial amount of both financial and material resources. As for the necessary resources, one can say the following. If the funding is secured, the resources will follow. It is simply impossible to calculate the exact volume of finances and resources needed to implement the entire project from the outset, since the RVK industry is being built from scratch, and there are too many unknowns for complete estimations. Therefore, we see the solution to this challenge only in a phased development of the project, focusing primarily on its investment potential, implementation schemes, and the prospective resource and technological capabilities of the regions where the RVK industry will be established. As the first stage of the project, the results of which will shape the entire initiative, we have divided the main RVK traffic into two halves, identifying its western and eastern segments. These will serve as testing grounds for the initial experimental batch of RVKs of all types and configurations, as well as for the setup of production lines, ground infrastructure, and flight operations. Stages of the production program. Stage 1. At the first stage, to supply the western and eastern segments of the RVK traffic with RVK units, the following facilities have been identified as necessary. 1. 2 RVK manufacturing plants, one in the Kaliningrad region and the other in the gas-producing area of Eastern Siberia and the Far East. 2 RVK units of the basic, simplified configuration, main modification, RVK BPSHM 3500, 3 units in total. Of these, 1 unit for the western segment and 2 units for the eastern segment of RVK traffic in Stage 1 of the NGSRBA project. 3 RVK units of the Northern Arctic configuration, Arctic modification RVK APSHM 3500, 2 units. Of these, 1 unit for the western and 1 unit for the eastern segment of RVK traffic in Stage 1 of the NGSRBA project. It should be noted that the general production program for establishing the RVK industry does not include building more units of this modification, as they will be constructed solely for test flights and for identifying specific structural requirements of the Arctic version, RVK APSHM 3500, as well as for developing the production technology for such units. Full-scale production of the Arctic modified RVK will begin only after the completion of the general production program for the RVK industry, which will be marked by the release of the main modification, RVK BP SHM 3500, in a total quantity of 3,263 units. This approach is necessary to avoid slowing down the pace of constructing the main RVK modification, since building a fleet of this version and ensuring its stable, reliable operation will serve as undeniable proof of the RVK industry's creation, and as a symbolic revival of the airship era. In case of urgent need for earlier production of the Arctic modified RVK or other variants, it is possible to allocate their manufacturing into a separate project outside the scope of the general RVK industry development program. 4. Hybrid Manned Emergency Rescue Lifeboat, GASSBMF-6, 5 units. Of these, 2 units for the western and 3 units for the eastern segment of RVK traffic in Stage 1 of the NVSH-PPV project. 5. Hybrid Micro RVK, RVK-GM-TD for telemetry and dispatching. 5 units. Of these, 2 units for the western and 3 units for the eastern segment of RVK traffic in Stage 1 of the NGSRBA project. 6. Facility for the production of deactivated hydrogen, supplying the required amount of gas for the RVK production program. 2 units. Of these, 1 unit in the Kaliningrad region and 1 unit in the Siberian region. 7. Facility for the production of helium, supplying the required amount of gas for the RVK production program. 1 unit in the Siberian and Far Eastern region. 8. Temporary specialized loading and unloading platform, pre-port RVK, 12 units. Of these, 5 units for the western and 7 units for the eastern segment of RVK traffic in Stage 1 of the NVSH-PPV project. This list defines the foundation of the production program for Stage 1 of the NGSRBA project development. It determines the locations of enterprise production sites, their capacities, volumes, and the order of financing. The total amount of investment required for the implementation of the first stage is €2 billion. Funding for the first stage is provided from the following sources. 1. Own funds of the holders and participants of the Third Dimension project. 2. Revenue from the commercial division of the Third Dimension project. 3. Investor funds. 4. Sponsor contributions. 5. Patron donations. The applied project implementation scheme allows for the use of venture financing, but with a high level of reliability and profitability, even at the first stage of the NGSRBA project. Calculations show that the overall return on investment, upon completion of the investment period, exceeds 1,000% on the invested capital, with virtually absolute reliability ensured by the absence of economic factors that could introduce risk. Stage 2. The second stage of the project involves the construction of RVK production facilities, RVK manufacturing plants, with a production capacity of 21 RVK units per year, as well as enterprises that provide the necessary technical and technological infrastructure. Funding for the second stage comes from 3 sources. 1. Project's own revenue from the implementation of Stage 1. 2. IPO, initial public offering. 3. Venture capital investments. The required funding volumes will be calculated based on the results of Stage 1 implementation. Stage 3. The third stage of the project involves the construction of RVK production facilities, RVK construction plants, with an annual capacity of 168 RVK units per year, along with enterprises providing technical and technological infrastructure. Funding for the third stage comes from 4 sources. 1. Project's own revenue from the implementation of Stage 1. 2. Project's own revenue from the implementation of Stage 2. 3. SPO, secondary public offering, a public offering of additional newly issued shares to an unlimited number of investors. 4. Venture capital investments. The required funding volumes will be calculated based on the results of Stage 2 implementation. Section 1.3. Flight, logistics, and service infrastructure. Flight, logistics, and service infrastructure are defined by the development of RVK production and the facilities that support its infrastructure. At the first stage, all infrastructure is built from scratch. Each stage of the project implementation is accompanied by reorganization, modernization, and expansion of the existing infrastructure. Section 1.4. Cargo and passenger RVK traffic. At the first stage of the project, the focus will be solely on establishing cargo-only RVK traffic. As the project progresses, based on the experience gained from the practical use of RVKS, including assessments of flight safety across various RVKS modifications, operating conditions, and route specifics, the possibility of developing passenger RVK traffic may be considered as a derivative of the cargo network. Part 2. General plan for establishing the RVK industry, consisting of 3 implementation stages. Stage 1. Industry for producing the main RVK modification RVK BPSM 3500, 5 units per year. Phase profile. Analytical, design, construction, production, and experimental operational phase. During this stage, the organizational, research, design, production, and experimental operational structure is created. Production and infrastructure facilities are built. Technological lines for manufacturing and infrastructure are set up, and RVKS are tested in real commercial flight conditions. The production program of Stage 1 is defined by the construction of facilities for manufacturing the required number of units specified earlier, as well as the organization of a full-cycle transport and flight infrastructure under conditions of real commercial RVK operations, ensuring the projected economic performance of Stage 1 of the NGSRBA project. The total synthesized estimated investment required for the implementation of Stage 1 is 2 billion euros. The actual investment volume will be refined during the design and engineering phase. Stage 2. Industry for producing the main RVK modification RVK 21 units per year, phase profile, analytical, design, construction, production, and operational phase. At this stage, through the design and construction of the required number of additional production facilities and infrastructure objects, the RVK industry is expanded to the target capacity set for this phase. RVKS are operated in real commercial flight conditions. The production program of Stage 2 is defined by the construction of facilities for manufacturing RVKs with a production capacity of 21 RVK units per year, along with enterprises that provide the technical and technological infrastructure for the RVK industry at this stage. It also includes the expansion of full-cycle transport and flight infrastructure under conditions of real commercial RVK operations, ensuring the projected economic performance of Stage 2 of the NGSRBA project. The required investment volume for Stage 2 will be calculated based on the results of Stage 1 implementation. Stage 3, industry for producing the main RVK modification RVK 189 units per year, phase profile, analytical, design, construction, production, and operational phase. At this stage, through the design and construction of the required number of additional production facilities and infrastructure objects, the RVK industry is expanded to the target capacity set for this phase. RVKs are operated in real commercial flight conditions. The production program of Stage 3 is defined by the construction of facilities for manufacturing RVKs with a production capacity of 189 units per year, along with enterprises that provide the technical and technological infrastructure for the RVK industry at this stage. It also includes the expansion of full-cycle transport and flight infrastructure under conditions of real commercial RVK operations, ensuring the projected economic performance of Stage 3 of the NGSRBA project. The required investment volume for the implementation of Stage 3 will be calculated based on the results of Stage 2. Thus, the launch of Stage 3 marks the beginning of RVK production at a rate of 189 units per year, along with a corresponding amount of supporting infrastructure. This production capacity will allow for the manufacturing of the target number of RVKs, 3,263 units RVK, needed to complete the entire project within 17 years from the moment the RVK industry reaches its full annual output of 189 units per year. In case of urgent necessity to achieve this result within a shorter time frame, the issue will be addressed by increasing production capacity through investment injections from an interested party. This does not refer to the release of additional RVK units for subsequent transfer to the investor. It concerns only the acceleration of the RVK industry development program. It is assumed that such an investor can only be the state, which would be capable of providing additional investment injections in the form of project financing. This matter will not be considered under any other conditions. Text, graphics, avatar, voiceover. Author of the Third Dimension project, Mikhail Shmelkov.
Make your choice today. Take part in the global project, Third Dimension. Detailed information on how to join the project immediately is available in the Participate in the Global Project Third Dimension section of our website. The link is provided in the video description. The road to humanity's new state begins here on Earth, and it is closer than it seems. You can step onto this road by taking the first step right now. By taking this step, you become an active participant in the implementation of the global project Third Dimension, the most ambitious initiative of the 21st century.